All right, in this lesson, we're going to talk about the last new piece you need for symbolization and predicate logic, which is the identity predicate. The identity predicate is a two-place predicate, like any others, that means X is identical to Y. The only thing that makes this predicate special is that we create a special symbol for it, and we use it across the entire system of predicate logic. It doesn't depend on any symbolization key. We use the equal sign for this predicate, and you don't have to include it in a symbolization key, and we know what it means when it comes to the symbolization after we separate those formalized sentences from a key. Technically, it should be written this way, right? The symbol for the predicate, the equal sign, then the two places for the singular terms, and it's X is identical to Y. This relation is reflexive, symmetric, and transitive. However, following the convention of the equal sign, you'll see it written like this. X equals Y as X is identical to Y, using that equal sign. This notation can be confusing and make you think of it's a connective between the singular terms. But remember that this is just a specified predicate that we write in a unique way. For instance, tilde A equals sign B means it is not the case that A is identical to B. It does not mean that B is identical to the negation of A or anything like that. It's just the negation of the whole predicate. So why introduce a special identity predicate? And it's because the way that the quantifiers work, we don't have a way of capturing in the symbolization the meaning of certain types of things. So one of those is definite descriptions, also specifying number, or exceptions and qualifications on statements. We're going to go through these one at a time and talk about them. So definite descriptions are descriptions that purport to specify conditions that are satisfied by exactly one thing. The example of the best indicator of definite descriptions is the word the. So if we say the US Vice President is a woman, when we say the US Vice President, we don't just mean a person who is a US Vice President. We mean there is the specific condition of being the US Vice President that is satisfied by exactly one thing. The same is true for the author of The Old Man and the Sea lived in Cuba. We symbolize definite descriptions using the existential quantifier and a universally quantified conditional that specifies uniqueness. That's what we need the identity predicate for definite descriptions. I'm going to talk about that uniqueness clause as we go through these two examples. So first we have the US Vice President is a woman. And if we think about this superficially, we might want to say there is an X such that X is the US Vice President and X is a woman. For the universe of discourse, we would have VX, X is the US Vice President, and WX, X is a woman. And we might symbolize it like this, right? There exists an X, VX, and WX. The problem here is that this symbolization just says there exists at least one thing that is a vice president and a woman. With this symbolization, there's nothing that tells us there's only one, right? That the person that is the US Vice President is a woman. So we need to add a clause that says that says for everything in the universe, if it's the US Vice President, it's this same person. And the way that we do that is by adding the clause, and for any Y, if Y is the US Vice President, then X is identical to Y. This might seem a little confusing right off the bat as to why we set it up that way. But what's going on here is we say that there is some X that is the US Vice President, and then we say you can pick anything out of the universe of discourse, and if it has this quality of being the US Vice President, then it's the same exact thing as X. So that's what we need to say, that being the US Vice President is something that uniquely applies to one individual, and that person is also a woman. So now let's start adding our brackets and parentheses. We have there is an X such that X is a vice president is the US Vice President and a woman, and we need to make sure that every occurrence of X is in the scope of this existential quantifier, right? We have an X here, here, and at the end of this consequent. So the whole thing needs to be in the scope of that existential quantifier. And now here's just the rest of the parentheses. We need to put the material conditional in parentheses for two reasons. One, we need to make sure that every occurrence of y, including this one here at the consequent, falls under the scope of this universal quantifier for any y. And also because we have this and here. This is the main connective of the sentence in the scope of the quantifier, right? We have this and we need to make sure that we know the whole material conditional is one of the conjuncts. On this side, we also use parentheses, right? Because we have another and we treat this conjunction on this side as the other conjunct of that main connective. So this is our completed symbolization. We have there exists an X such that X is the US Vice President and X is a woman. And for anything in the universe of discourse, if for any Y in the universe of discourse, if Y is the US Vice President, then X is identical to Y. So this says there is a US Vice President that is a woman, and this says there is only one US Vice President, and it's this woman. So let's quickly go through this second example. We have there is an X such that X is the author of The Old Man and the Sea and X lived in Cuba. And then the uniqueness claim, right, that uniqueness part is exactly the same as it was in the first example. And for any Y, if Y is the author of The Old Man and the Sea, then X is identical to Y, right? This is the exact structure you're going to see for any definite description. Here we have all of our parentheses and brackets added in. These are in the same exact places as the last example. Here we have our universe of discourse, people and books, our two-place predicate, X is the author of Y, CX, X lived in Cuba, and then O for the book, The Old Man and the Sea. And here's our completed symbolization. Notice that the structure is exactly the same as that last example, right? There is some X that is the author of The Old Man and the Sea and lived in Cuba. And for any Y in the universe of discourse, if they have the property of being the author of The Old Man and the Sea, then they are identical to X. So there's just one author of The Old Man and the Sea, and that person lived in Cuba. Now let's talk about counting. In natural language, we often specify numbers of things, right? John has one sun, Jupiter has at least 2 moons, Mars has exactly 2 moons. And we use identity to capture the meaning in symbols because the quantifiers alone can't do it. Let's look at these 3 examples. John has one sun. Here we're specifying that something has the property of being John's son, and it's the only thing that has that property. So we're going to do it the exact same way that we did for the definite descriptions, right? There is an X such that X is the son of John, and for any Y, if Y is the son of John, then X is identical to Y. So when we're specifying that there's only one of something, it's exactly the same as a definite description. Here's our symbolization key. Let's add in our parentheses here, right? One for the whole scope of the existential quantifier, and then one around the material conditional to put the whole thing in the scope of the quantifier for Y. And the symbolization we get looks like this. There exists an X such that X is the son of John, and for all Y, if Y is the son of John, then X is identical to Y. This clause here should start looking really familiar to you. It's the same as the other 2 examples, right? Some of this stuff is really hard to get started with, but once you recognize the structure and learn how to plug different sentences into it, it becomes much easier. So now we're going to do something a little bit more complicated. Now, instead of specifying there's only one of something, we want to specify that there's more than one. So we might think to try to do it like this, right? There is an X such that X is a moon of Jupiter, and there is a Y such that Y is a moon of Jupiter. The problem with this is this just says Jupiter has a moon and Jupiter has a moon, right? This sentence could be true if Jupiter had only one moon, and we would just point at it the first time as the exists in X, and point at it the second time as the exists a Y. It doesn't do anything to tell us there are at least two. So now we're going to change the structure a little bit, and we're going to put the existentials together on the conjunction, right? There is such an X, there is such a Y, that X is a moon of Jupiter and Y is a moon of Jupiter. Now this by itself doesn't fix the problem, right? We still could say, all right, there is some X, find that X, it's a moon of Jupiter, and then we could pick out the same individual thing such that there's a Y that Y is a moon of Jupiter. We need to add something that specifies that X and Y are not the same moon. And that's exactly what we do, right? We add another conjunction and say it is not the case that X is identical to Y, right? So there's an X and there is a Y. X is a moon of Jupiter and Y is a moon of Jupiter, and X and Y are not the same moon. It is not the case that X is identical to Y. So here's our symbolization key. And this is that completed symbolization, right? There exists an X, there exists a Y. The whole sentence is within the scope of these two quantifiers. We say that X is a moon of Jupiter and Y is a moon of Jupiter, and X and Y are not identical. It is not the case that X is identical to Y. So now let's look at Mars has exactly two moons. We're going to start with the same structure we did in the last problem, right? There is such an X, there is such a Y, that X is a moon of Mars and Y is a moon of Mars, and it's not the case that X is identical to Y. Now this tells us there are at least two moons, right? It doesn't tell us that there are only two. So we need to add a clause, a uniqueness clause, that says that there are only two. And the way that we're going to do that is very similar to the uniqueness claims that we made when we said there were only one, but this time it's going to involve a disjunction in the consequent. So we're going to say, and for any Z, we need a new variable because we've already used X and Y. If Z is a moon of Mars, then Z is identical to X or Z is identical to Y, right? So this says there are two moons of Mars. Those moons are not identical to each other, but for anything else, if it's a moon of Mars, then it's either one of the two we've already identified. This says there are two and there are no more than two. So now let's add in our parentheses, right? First, I'm going to do brackets for those existential quantifiers. Then I'm adding in the parentheses for the universal quantifier for Z, right? It needs to be around this whole conditional. And then last, I've added in parentheses that just make sure the structure makes sense, right? We need the consequent here in parentheses because it's a disjunction. Z is identical to X or Z is identical to Y. That whole disjunction is our consequent. And then we need parentheses to break up these two ands, right? We have X is a moon of Mars and Y is a moon of Mars, and it's not the case that X is identical to Y. So I threw in some parentheses here to break those up. And then we have this and as our main connective of the quantified sentence, where one conjunction is this complex conjunction, right? It includes this whole side, and the other side is this material conditional. So now let's do our symbolization key. It's exactly the same as the last one, except we're doing M for Mars instead of J for Jupiter. And the completed symbolization looks like this, right? Now this problem is a lot more complicated than anything you're going to see on the exam, but I want you to understand how they work, right? And if you're a huge logic nerd, you can actually go do this with 3 or more. It's the same exact structure, it just keeps getting bigger and more complicated. But what this sentence says, this side says there's an X that's a moon, there's a Y that's a moon, and they're not identical to each other, right? This says there are at least 2 moons. And this says for anything you pick out in the universe of discourse, if it's a moon of Mars, then it is identical to X or identical to Y. So this side of the conjunction says there are at most 2 moons. All right. Now let's move on to counting and just briefly talk about exceptions and qualifications. So there are a couple of different ideas I have in mind here, and identity is really useful for capturing these, especially comparative qualifications. So we're going to look at these two examples, and then I'm going to end this video because it's already pretty long. Every developed country except the US has universal health care. Right, so we're going to use this as our universe of discourse. Our universe of discourse is countries. We have DX for X is a developed country, UX for X has universal health care, and then lowercase u for the United States. Now, this is a every developed country has universal health care statement, right? Just with the exception. So we're going to do it the same way we do all A's or B's statements. And we're going to say for every Y, if Y is a developed country and it's not the case that Y is identical to the US, then Y has universal health care, right? So it's the same structure we've already been using since the second lesson of this section of identifying all A's or B's, but now we need to say it's a developed country and it's not the US. But we're not quite done with capturing the meaning of this sentence. Right? For every Y, if Y is a developed country and it's not the case that Y is identical to the US, then Y has universal health care. That says every country that's not the US has universal health care. But when we think about exceptions, right, every developed country except the US has universal health care, it also has the meaning that it's not the case that the US has universal health care. We need that second part beyond the conditional, because just this part symbolized wouldn't say that the US doesn't have it, right? If the US does have it, the antecedent would be false and the conditional would still be true. So we need to add that part at the end there for cases that involve exceptions. So now let's start breaking this up, right? We have for every Y, and then we have the whole material conditional in this outer set of parentheses, right? Because we have Y here in the consequent. And then we have the antecedent in parentheses if Y is a developed country and it's not the case that Y is identical to the US. And then we get this symbolization, which is a little messy because I used U as both a predicate and an individual constant. But we have for every Y, if Y is a developed country and not identical to the US, then it has universal health care, and it's not the case that the US has universal health care. So now let's talk about the last example. The most expensive city in the world is in China. Our universe of discourse is countries and cities. IXY is X is in Y, EXY, X is more expensive than Y, CXY is a city, and then little c is China. This is a comparative clause, right? We have a definite description, the most expensive city in the world. And the way to specify that is not with a predicate, but by comparing it to other cities, right? So we're going to start. This is what we need to say, right? There is an X such that X is a city, right? Because we're saying it's the most expensive city, and X is in China, right? Exactly as we did with definite descriptions. And now we need to say it's more expensive than any other city. So for any Y, if Y is a city and it's not the case that Y is identical to X, then X is more expensive than Y. And it's not the case that Y is identical to X is important here, right? We need to say that X is more expensive than any other city. So we need to add the negation of the identity claim to specify that we're talking about other cities. If we just said for any Y, if Y is a city, then X is more expensive than Y, then X would be a more expensive city than itself, which doesn't really make sense. So now let's add in those brackets, right? I have the two quantifier scopes, the brackets around the whole thing, and then the parentheses around the material conditional to put it in the scope of Y. And then we add the last parentheses just to make it make grammatical sense, right? If we put this subconjunction, right, X is a city and X is in China in parentheses, so that that sentence can be one of the conjuncts for the and. And then we put the antecedent in parentheses as well because it's a conjunction, right? Y is a city, and it's not the case that Y is identical to X. So the symbolization we get is this, right? We've got X is a city and X is in China, and for any Y, if Y is a city that's not the same as X, right? So any city other than X, X is more expensive than all of those cities. That's the end of this lesson, and I do want to reassure you that that is the last complication I'm throwing in for symbolization. You now have all of the pieces of everything we need for the symbolization portion of exam 3. Next time we are going to start doing evaluations of predicate sentences using interpretations, but for now, let's just focus on this. These are the pages of the logic book that talk about the identity predicate. It's very useful material. I would look at that if you're still a little confused. And then these are the practice problems I'm going to recommend you look at. I will be making a video going over those problems shortly.